Alright, got some weirdness here. What we have is a counter implemented with analog circuitry laid out like this. This is incredibly meaningful, I know. We have an initialization circuit here with a variable initial increment rate coming in here. And these are three elements that basically compose a toggle flip-flop, except it's analog, so it actually counts up from 0 to whatever the full voltage is using this stuff. I'll detail this elsewhere. But the interesting thing is this weird phenomenon. If you're incrementing the initiator by 1 and then you change the increment cycle, you can get some radically unexpected behavior. You can begin getting a thrashing between two values, and that can be illustrated as seen here. We've got the 12 volt supply going in to feed the amp. We're monitoring channel 0, and we have our increment ratio set to something fairly large. So we're seeing this is 100 microseconds per division, and so we're seeing about 150 microseconds for the total period. 6 to 8 hertz nominal speed. That's about what we expect. The input rate is set to its maximum. If we cut that down to a value of about 1/8, we should cut the speed down by 8. And when we do that, we notice that we get something like what we'd expect. We get a big pulse every second, but we're getting a lot of noise in there, and that noise is actually oscillation, where the feedback of the flip-flop is thrashing. But I can raise this input here, which I've set up to be a control line, which will clear the initiator, and then when it comes back down to 0, we get a nice clean beat coming out once per second. It's an interesting phenomenon that comes from having more than 2 possible values. You get this ability to actually thrash between almost chaotic values. That's kind of interesting.